Hi, this is Aishwarya. I am currently working as an assistant professor in the Department of ECE at SNS Institutions. So, we already discussed in previous session about frequency response. So, this session is fully about frequency compensation. So, I already told you in previous session that is AC characteristics having 4 parameters that is used to check the behavior of the operational amplifier by using AC signals. The first parameter is about frequency response and second one is about frequency compensation. Third one is about stability of the operational amplifier and last one is slew rate. Okay. So this session is fully about frequency compensation. So frequency compensation is used to reduce the roll of condition so that it consisting of 2 types, that is internal compensation and external compensation. In external compensation having 2 types, that is dominant pole compensation and pole zero compensation. The first one is about dominant pole, that is dominant pole compensation. In this dominant pole, the diagram is, so this is about dominant pole diagram. So this is our operational amplifier. Okay. So by using this, we have to check the output of this dominant pole. Okay. So uncompensated output we discussed in previous session. That is, what is that? A equal to AOL divided by 1 minus F by F1, 1 minus F by F2 and 1 minus F by F3. So this is uncompensated value, uncompensated gain value. Okay. So our in dominant pole we have to calculate the V0 value. By using that we have to compensate this uncompensated value. Okay. So we already know that V0 means output voltage, that is component across the voltage divided by total component in the resistor, right? So that V0 is written here as V0 equal to, what is that? Minus j omega c by R minus j omega c. Okay, R minus j omega c. So in this total component means, this A means gain value and V, so that A into V. Okay, we know that V0 by V is our gain value, so that I write it here as A1. So minus j omega c by R minus j omega c into A. Okay, into A. So here 1 by j omega c. This is written as 1 by j omega c. After that R0 by 1 by j omega c into A. Then A1 equal to, what is that? 1 by j omega c or j omega c minus 1 by j omega c. This value is eliminated. After that A by 1 minus r j omega c. We will take the value as here. Then we know that omega value is 2 pi f. So we write that our omega value is 2 pi as, that is A1 equal to A by 1 minus R2 pi f c. Okay, R2 pi f c. So this R2 pi c is about, what is that? Corner frequency value. That is f equal to 1 by 2 pi rc. So here the corner frequency is Fd. We write it as Fd. So A1 equal to A by 1 minus F by Fd. So this is for the gain value of dominant pole. We have to apply this value into our uncompensated gain value. Yes, A equal to AOL divided by 1 minus F by Fd into 1 minus F by F1 into 1 minus F by F2 into 1 minus F by F3. 3. So this is our dominant pole gain value. So the graphical representation for this is, so this is our gain and this is our frequency. So this is normal F1, F2 and F3, right? So dominant, by using this dominant pole we have to reduce here, okay? We have to reduce the value here so that this is uncompensated value and this is compensated value. So this is about dominant pole compensation. It is the first type of external compensation, okay?